Section 2.3 is all about the basic limit laws, which will allow us to evaluate many limits. The first three limit laws can be summed up as saying that limits add, scale, and multiply. More specifically, if you have some simple pieces, the limit of f of x and the limit of gx as x approaches the same number c, then you can combine them with addition and multiplication and scaling by constants, and they will behave the way that you expect. So for instance, if you wanted to calculate the limit of 2x minus 1 as x goes to 7, you could think of that as twice the limit of x plus the limit of minus 1. In section 2, the first theorem gives us the limits of these basic building blocks. So this limit is just 2 times 7 minus 1. We see here that phenomenon mentioned earlier, that you can calculate a lot of limits by just plugging in x equals the limit point c. Here, we just plug x equals 7 into the equation 2x minus 1, and out pops the correct answer. This method, called the substitution method, is going to be developed further in section 2.4. It doesn't always work. First of all, division by 0 is causing a problem. Also, when we take roots, we can't take even roots of negative numbers. So these basic limit laws are powerful, but they don't tell us everything we need to know about limits. Using those building blocks from section 2.2 and these limit laws, we can build up the limit of any polynomial, and we can also take most limits of rational and algebraic functions. We just have to be careful not to divide by 0 and not to take even roots of negative numbers. There's one other caveat, which is that when this says that the limits of f and g exist, it means they exist and are finite. Infinite limits don't really behave the same way that finite limits do. When you combine them, you can get unpredictable results. Use the list of recommended problems to get practice applying the basic limit laws and recognizing when they do not apply.